Hello and welcome to my Pre-Algebra review series. This video covers Chapter 7, Section 7, entitled Transforming Formulas. By the end of this video, you should have a better understanding of solving formulas for a given variable and using formulas to solve problems. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it will help this channel be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's do some math. Okay, Objective 1, solving formulas for a given variable. Remember that a formula shows the relationship between two or more quantities. You can use the property of equality to transform a formula to represent one quantity in terms of the others. So let's do a transforming in one step. Solve the area formula, A equals length times width for L. Area equals length times width. Okay. So we're going to start off by writing that A is equal to length, A here is equal to the length times the width. That's pretty, I think we all know those by now. It's a common formula. And in one step, we're going to be able to switch this to be able to solve for the length. So we're going to take and solve this for L, means we have to divide. We can pretend like W is the coefficient of the L, since it's multiplied by the L. We want to get the L by itself. So we have to move the W to the other side of the equation. And in order to do that, we have to do what? We have to multiply by the multiplicative inverse of W. And the multiplicative inverse of W is 1 over W. So that's what we've done here. We're multiplying each side of the equation by 1 over W. Okay? So now when we do that, the W on this side of the equation is going to cancel out, and we're going to be left with the L. And then the other side of the equation, we're going to have A divided by W. And that's exactly it. The area divided by the width is equal to the length. Or you can write it the other way. It can be the other way. The length, so it doesn't matter which way it is, the equation can go either direction. So under check your understanding, we have 3 different formulas here. Let's try a few of them. Solve for the variable in red. So in the first one, an A here, we have P equals S minus C. And they want us to solve for S. So that means it's going to be S equals something. Well, what is S going to be equal to? In order to get that, we have, just like any other 1 or 2 step equation we've been solving all along here now, we have to get the S by itself. To get the S by itself, we're going to subtract the minus or add a minus C to both sides. So if we're going to take P plus C, because it's the minus C, we've got plus C is equal to S minus C plus C. Well, these two cancel each other out, so we're going to have P plus C is equal to S. So we've just, and you can write it, S is equal to P plus C. Because it's an equation, we can flip these back and forth without any concern. Now, how about doing B? H is equal to K divided by J. And we want to solve for the K. Well, the K is right here on top, and we can have the K on this side. So all we're going to have to do is worry about getting rid of the J. So how do we get rid of that J? We have to multiply as if this is the coefficient, and it is, the coefficient of the K variable. We can multiply by the inverse of this, and the inverse of 1 over J is J. J over 1, the inverse. So we're going to say that H, we're going to multiply both sides, times J is equal to K over J times J. These J's cancel, and we're left with the K. So we have H times J is equal to k. And now let's do c. Now we've got three variables, a p, an r, and a t. I equals PRT. And this is actually an interest formula. Interest is equal to principal times rate times time. But they want us to solve for the principal, as if we were going to be doing an investment problem here. But in this case, the r and the t, right here, the r and the t are like in the case for the j or the other ones in the past. This is like the coefficient of p. So we have to multiply by the inverse of this coefficient in order to get the p by itself. So what are we going to do? We're going to say we're going to multiply by the inverse of RT, I times 1 over RT. We're going to do them both at the same time, is equal to P times RT times 1 over RT. So the RT times 1 over RT cancel, and we're left with I over T, RT. We can write it I over RT is equal to P. Okay? So now we're going to look at some formulas that take using more than one step to solve the formula for the new variable. So in our case, it says solve the perimeter formula, where P, perimeter, is equal to 2 times the length plus 2 times the width. And they're going to want us to solve for L. So we have to undo a few things in here to get L by itself. But what you're going to see, it's not really that difficult to do. So we start off by rewriting the equation. P is equal to 2L plus 2W. That way we can say, yep, we're working on the same problem, one-to-one relationship. Because this was probably written and typed on your test. You need to write it over again so that you can have it in your work area. Okay? So now in order to get started, we're going to move the 2W away from the side with the L, the variable, the variable we're looking for, L. We're going to get the 2W on the other side. So in order to do that, we're going to subtract 2W from both sides. So we have a 2W here we're going to subtract, and a 2W here, which is subtracting from this 2W. This is a negative and a positive. So when we do that and simplify it, we're going to get P minus 2W, here's the minus 2W, is equal to 2 times L. So now the L is almost by itself. We have to get rid of the 2 also. Okay, so in order to do that, now we're going to do some multiplying or dividing to do that. So we have to multiply the L variable by its coefficient, the inverse of its coefficient, which is 2. The inverse is 1 over 2. So we're going to multiply both sides by 1 over 2. And when we do that, we see that we have 1 over 2 times this whole quantity here. And that's, you have to treat it this way. You have to do each item. The entire side has to be multiplied by the half. Not just any one of these, the entire side. So we have these parentheses here, which kind of helps you realize, oh, this whole thing needs to be multiplied by half. Just like you're going to multiply this whole thing over here by half, and when you do, it's going to cancel the 2's here, and you're going to end up with an L all by itself. But on this side, you're going to end up with a 1/2 P minus W. And how did you do that? Because then you took the distributive property and you said 1/2 times P minus 1/2 times 2W. And the 2 here and the 2 and the 2W cancel each other, so it ends up being minus a W by itself. And you didn't have to do this. If you chose to, you could have done both of these multiplications when you were originally multiplying by the half. You could have said immediately, oh, I have to multiply the 2L by a half, and I have to, on this side, I have to multiply the P by 1/2, and I have to multiply the minus 2 over 2W by a half. And you would have ended up with the same answer. But to me, this, with the parentheses here, makes it clear that you're multiplying the entire side, everything that's on that side, by the half. In fact, really, when you get down to it, you're going to have to do the same thing for both sides, but that's how I've got this figured out. Okay? So let's do some problems. Let's try a few. We're going to check our understanding here. We're going to solve for the variable indicated in red. Hopefully this won't be too hard. Let's take a look. So we have 5a plus 7 equals b. And they want us to solve for the a. So that means we have to get the a by itself. It means we have to get the 7 over here and the 5 somehow to the other side. So the first thing we're going to do is we're going to get rid of the plus 7. So we're going to say 5a plus 7 minus 7 is equal to b minus 7. Now that we have that, the 7's cancel. We have 5a equals b minus 7. So now we have a 5a. So we have to take and get rid of the 5 to get the a by itself. So we're going to multiply by the multiplicative inverse of 5, which is 1 over 5. So 1 over 5 times 5a is equal to the whole quantity here, b minus 7 times 1 over 5. And now we're going to get this, 5s are going to cancel. A is going to be equal to b, oops, I wrote a 5, sorry, b over 5. I'm just going to erase that if you don't mind. B, try it again, b over 5 minus 7 over 5, minus 7 over 5. So that's the answer to that problem. And this one over here, we have P is equal to 2L plus 2W. That's like the problem we had on the other page. We're just going to solve for W this time. So now we have P is equal to 2L plus 2W. I'm rewriting the equation. So now we want to get the W by itself. So we're going to move the 2L. P minus 2L is equal to 2L minus 2L, okay, plus 2W. So the 2L's cancel. So we have P minus 2L is equal to 2W. We have to get the W by itself, so I have to get rid of the 2 in front of the W. So we're going to multiply by the multiplicative inverse of 2, which is 1/2. So we're going to say P minus 2L, the quantity, over 2 times 1/2 is equal to 2W times 1 over 2. The 2's cancel, and we're left with W on this side. And on this side, we have P over 2 minus L, because the 2's cancel. So W is equal to P over 2 minus L. This one over here, Y is equal to X over 3 plus 8. We're solving for X. So Y is equal to X over 3 plus 8. Y minus 8, because we're going to multiply both, add minus 8 to both sides to get rid of the 8. Minus 8 is equal to X over 3 plus 8 minus 8. The 8's cancel. Y minus 8 is equal to X over 3. And Y, I'm just going to do this. I'm going to multiply each side by 3, the reciprocal of 3, of 1 over 3. Y times 3 minus 8 times 3 is 24, is equal to X. So I'm writing here, X equals 3Y minus 24. Okay? So in Objective 2, we're going to be using formulas to solve real-world problems. You can transform formulas to solve real problems. We're going to see some right here. Example 3, a real world problem. You plan a 425-mile trip to Bryce Canyon National Park. You estimate you will average 50 miles per hour. To find about how long the trip will take, solve the distance formula, d equals r times t, or distance equals rate times time, for the t variable, for the time, because that's what they want. We want to solve for time. Then substitute the t that we find into the variable and see what we end up getting. Okay, so we're going to write the equation here, and it's d is equal to r times t right here. Then we're going to get rid of the r with the t because we want to get the t by itself. We're solving for t. So we're going to multiply by 1 over r, the inverse of r, and we're going to do that on both sides of the equation. So here's the 1 over r here, and we're multiplying by 1 over r on this side, and the t is still here. So when we do that, we end up with d divided by r, the d divided by r, is equal to t because the r's cancel each other. R's cancel each other out here, and you end up with t. So now we're going to substitute in our variables. So now that we've got a time formula, so we can determine how long it's going to take, we can say 425 miles to the trip divided by 50 miles per hour. And the answer will end up being in time. So if you divide 425 by 50, you're going to get 8.5 hours is equal to the time. So it takes about 8.5 hours to do this 425 miles at 50 miles per hour. So in this problem, we're going to do the same problem we just done. The d equals r times t. Distance equals rate times time. But we're going to solve for the rate instead of the time. It's just the same problem. We're just going to look at it differently. So all we have now is d is equal to r times t. But this time we're going to get the r by itself. And to do that, we have to multiply by the inverse of t, which is 1 over t. So we have to multiply each side by 1 over t, each side. And when we do that, we'll get r on the one side is equal to d divided by t on the other side. When we put in the 425 and the 8.5 that we found in the previous example, or previous problem, 425 divided by 8.5 is equal to r. And what is that equal to? Well, guess what? It equals to 50, just like the other problem said. So r is equal to 50. So we've solved this a couple different ways, the same problem. And here again, we have another real-world problem. An exchange student in your class wants to know the Celsius equivalent of 77 degrees Fahrenheit. First, solve the formula for C. What we're going to do is solve it for Celsius, because this is the formula for Fahrenheit that's on the screen. So the formula for Fahrenheit is Fahrenheit, the temperature in Fahrenheit is equal to 9 over 5 times the temperature centigrade plus 32. So we're going to rewrite this to try to solve it for C and come up with what is the centigrade value for the 77 degrees Fahrenheit. So we have the formula. F is equal to 9/5 C plus 32. So we need to get rid of the 32 to get the C by itself. So we're going to subtract 32 from both sides. So here we are subtracting 32 from here and 32 from here. And you end up with F minus 32 is equal to 9/5 C. So now we have to get rid of the coefficient, which is 9/5. And in order to do that, we have to multiply by the inverse, or the multiplicative inverse, or the reciprocal of 9/5. And that is 5/9. You just flip the fraction over. So we're going to multiply both sides by 5/9. So 5/9 times 9/5 C is equal to 5/9 times the quantity F minus 32, or Fahrenheit minus 32. So on this side, we know now that these are going to cancel. The 5/9 is going to cancel. We're going to just the centigrades on this side. And here is literally what it's going to be, the formula. So we're going to say 5/9 times the F, and actually we could do them separately, or just we'll leave it the way it is for now. So we have F, we're going to substitute in 77 degrees, right up here, the 77 degrees. We're going to substitute that here, 77, and we're going to subtract 32 from it. And when we do that, we're going to get, what do we get? We get 45. 77 minus 32 is 45. And 45 divided by 9 is equal to 5. And 5 times 5 is equal to 25. And there it is. Here's the 25. So C is equal to 25 degrees Celsius, when in Fahrenheit, the thermometer says it's 77. Let's check another problem here, see if we truly understand this. Let's solve the batting average formula. A equals H over N. Solve for H. Find the number of hits a batter needs at 40 at-bats, N, to have an average of .275, or a 275 batting average. So the formula we're looking for is H is equal to A times N. We did that by switching right here. The formula was A equals H over N, and we have to move the N to the other side, so we get A times N is equal to H. That's what this formula is showing us right here. Okay, so A is equal to H over N, and we're going to rewrite it by multiplying both sides by N. See it? Both sides by N. And then we get AN is equal to H. The same thing here. H is equal to AN. So 275 is the A, the average that we're looking for. And N is the number of hits. It's 40. 275, 40. It's the at-bats rather, excuse me, not the hits, it's the at-bats. And how many hits did we have to have at 40 at-bats to have a 275 batting average? Well, if you take 40 times 275, you end up with 11. So you need 11 hits to get a 275 batting average at 40 at-bats. Our final slide here are some exercises. I just want us to try a few more just to make sure we have and we understand what we're doing. So let's go. So we have V is equal to L times W times H. V probably is volume, is length times width times height. Okay? So they want us to solve for width. So we're going to say we have to get rid of the L and the H. These are coefficients of the W. You can think of it that way. Coefficients of the W. It could be written W, L, H. And then you'd see that the L and the H are coefficients of the W. So to do that, we have to move the L and the H to the other side. Get the W by itself. So to do that, we're going to multiply by the inverse of L times H. And the inverse of L times H is V times 1 over L H is equal to, now we have the L W H times 1 over L H. Right there. And these cancel. The L's cancel. The H's cancel. LH's cancel here. What's left is the W. And over here we have V over L H is equal to W. So the width is equal to the volume divided by the length times the height. Let's do B. 2/3 M minus 5 is equal to N. So we got to move the minus 5. So 2/3 M minus 5 plus 5 is equal to N plus 5. So the 5's cancel. Now we got to get rid of the 2/3, and we're going to do that by multiplying by 3/2, the inverse. So 3/2 times 2/3 M is equal to n plus 5, the quantity, right, times 3 halves. 3 halves. So this whole thing has to be multiplied. This whole number has to be multiplied by 3 halves. So m is equal to 3 over 2n plus 3 or 15 over 2, if you will. It doesn't work out well, but we can just leave it like this if we want to. We can literally leave it like this. Is the quantity n plus 5 times 3 halves. Okay, C. V, volume, is equal to 1/2 pi r squared h. Okay, so let's solve this for h. That means we have to move all of this stuff here in front of the h to the other side. And we're going to do that by dividing it out or multiplying by the multiplicative inverse. Well, that's easy. V times 1 over 1/2 pi r squared. 1/2 pi r squared. Okay, so that is equal to 1/2 pi r squared h times 1 over 1/2 pi r squared. The 1/2 pi r squareds cancel. We're left with h on this side is equal to v divided by 1/2. I'm going to be moving this, by the way. 1/2 pi r squared, not h. I got to, sorry. R squared. Okay? And I'm going to rewrite it up in here to make it clear. But the half should probably be moved out from here and put it in the denominator. So we could say, in this case, 2v divided by pi r squared is equal to h. We could have done that. To get the half up to the top, we have to multiply. We have to invert and multiply, so you just put the 2 on the top, so it ends up being 2 over 1. So that's the answer to that one. And D, here, A, the area equals 1/2 A plus B times H. That's what I'm assuming they're doing here. Area problem. So to solve this, they want us to solve for H. Same problem. It's almost exactly the same as one we just did. This entire piece up front here needs to move to the other side. And it needs to move to the other side by dividing by the entire thing. So we're going to say A divided by 1/2 the quantity A plus B times H. Oh, no, not times H. I did that last time too. I'm sorry. Sorry about that. Is equal to 1/2 the quantity A plus B times H divided by 1/2 A plus B. So these half A plus B's cancel each other out, and you're left with the H over here. And this can be left the way it is. We can multiply it out. We could say 1/2 A plus 1/2 of B, or you could do the inverse on the half and write 2A over A plus B is equal to H. Okay? Let me write it up here nice and maybe make it clear up here. right down here. It could be 2a over a plus b is equal to h. That could be our answer for that one.